What I'm going to do instead is just refer you to the textbook, and you'll see example 15 on page 530 has an algebraic approach to this, which is a real hassle, and it can be done, but it takes time, and you end up having to solve a set of 9 simultaneous equations. Although that works out quite simply, so it's not too bad. It's not too bad if you have zeros and ones. Lots of ones is a bit of a pain, but if you've got some zeros in there, that simplifies things quite nicely. So it's not too bad to do pen and paper, but you can calculate the, I think that says invoice. You can calculate the inverse on your calculator as well. So if you want to calculate the inverse of a matrix, then you just need to go into your option menu, matrix vectors, and it should be here somewhere, identity.
Can't you just go to the power when I go to 1?
Yeah, that's a good point. Let's just do that. So if I go back to the main screen and I click on matrix vectors, no, I don't want to do that, I don't want to define it. Maths, and then matrix vectors, I can input 3 by 3 in one go. So I'm going to do that. I get 1, 2, 1, 0, 1, negative 2, 0, 1, 1. And I've set that up for my 3 by 3. That was in the main screen, and then math, and then F1. And now I'm going to raise that to the power of negative 1. And it gives me this. So 1, 2, 1, 0, 1, negative 2, 0, 1, 1 to the power of negative 1 equals 1, negative 1/3, negative 5/3, 0, 1/3, 2/3, 0, negative 1/3, 1/3. So there you go. So you can do inverses quite easily, just following that process. So with that in mind, and now I've got that inverse on my calculator, I'm going to come down and do example 7. In example 7 it says solve this equation, but you notice this is not like what we've been dealing with before, because we're solving this equation but it doesn't come out with the identity. This is where this is important. So I'm going to determine, I can't do, because X is not an identity matrix, I cannot do AX A inverse. I have to do left-hand side multiplication because I'm trying to eliminate this matrix to get X by itself. In the number system, you just divide by whatever that is. In matrices, you have to multiply it by its inverse to make it the identity, which means it's removed. So I'm going to do that. AXB, that gives me, I want to do A inverse times by 1, 2, 1, 0, 1, negative 2, 0, 1, 1. X is equal to A inverse times by 4, negative 3, 7, 1, negative 3, 3, 1, 0, 3. Now I've worked out A inverse, I've written it above. It's on my calculator as well. So I'm going to get that matrix on my calculator and I'm going to multiply it by, let me see if I can get this to work. Answer, no, shift answer times a 3 by 3. And I'm going to input into that 3 by 3 my B matrix here, which is 4, negative 3, 7, 1, negative 3, 3, 1, 0, 3. And execute that. And it gives me an answer of 52, negative 39, 91, 13, negative 39, 39, 13, 0, 39. If I multiply by A inverse on the other side, I will get a different answer, and it'll be the wrong answer. This gives me I times X, and so this just gives me X. And so X is equal to that thing there. And so that's using this thing in orange, this concept in orange. If you've got AX equals B, then you have X equals A inverse B. If you have XA equals B, then you have X equals BA inverse. So make sure that you multiply on the right side. Are there any questions on that?
Can you scroll?
I can scroll up.